Hello, chat. Did you enjoy the music? That was from Prokofiev's 64th opera, um, the first act, which was Dance of the Nights. It was the whole thing was called Romeo and was about Romeo and Juliet, but the first act was Dance of the Nights, and I think that piece is quite lovely. So today we're doing a little DIY. That's what I'm thinking we're gonna do. That's what I'm thinking I'm gonna do. Um, and I like to make things that are I like things that are kind of deadly. I like things that are a little bit dangerous, but but we run into some rules a lot. So there's a lot of things that I would like to show that you really can't. You really can't, unfortunately. Um, if we switch over to that. Maybe move this out of the way a little bit. Let me move you up, me over. Anyone there? Anyone there? Anyone watching? Let me see. There's viewers. I'm wondering if my chat might be glitched out. It might be. If I don't see anyone, I might check to make sure that that's not glitched out. Oh, there we go. Hi Squishy. Yeah, we're doing some DIY. We're doing a little bit of DIY. And we're gonna make something fun. And you might think, oh, hey, YouTube's community guidelines. That's not allowed. We're not allowed to give instructions on how to make explosive devices or compounds meant to injure others. And you might think, oh, if you make a device with either a rocket with a propellant of more than 4 ounces or a missile with an explosive or incendiary charge of more than a 1/4 ounce, that is a destructive device under the NFA, and you need a tax stamp for that. But it's 3 a.m., so I might have to catch the VOD. But I like where things are going. Yeah. So, here's the thing. We're going to be making something that actually does not contain any explosives. What we are making is what's called a lazy dog, and it is a kinetic projectile, which means it is a solid steel. It is a solid chunk of steel with some fins on it, which is what it is. And they were primarily used during the Korean and Vietnam Wars. And what they would do is they're very, very cheap to manufacture, at least industrially. They're a little bit harder at home, but we're going to try to make it happen. Primitive gun type thing? No, it's not a gun. It's a kinetic projectile. And what they would do is they would have boxes of these in helicopters. And whenever they would fly over a group of enemies, they would throw them out, and when it would get up to terminal velocity, like the fastest speed it would fall when gravity matches up with the air resistance. At terminal velocity, it would be lethal. So throw these out of a aircraft from high enough, and they're pretty deadly. But it's just a chunk of metal. It's just a chunk of metal, and I think they're pretty cool. I want to make one. And you might think, oh, hey, didn't I did a thing already do something like this? And he did, which is why I know this for certain isn't against the YouTube terms of service, is it? Because if it was, wouldn't he get in trouble? Wouldn't he get in trouble if that were the case? Like throwing pennies off the Empire State Building. Yes, exactly. Exactly, except it's a chunk of steel with fins on it. And so what are some of the advantages of this? It's very cheap to mass manufacture. I'm not going to be mass manufacturing. I'm just going to make one. And the other big advantage is, the purpose is anti-personnel. Like, it's not like anti-material. It's mostly anti-personnel. You don't have UXO, which is unexploded ordnance, which is kind of important when you're, bombing civilians. You don't want UXO exploding the other unarmed civilians in, say, Papua New Guinea or in Myanmar. That's a thing. Yeah, so they're pretty cool. They're pretty cool. They're once they hit the target, then they're essentially inert, which is very cool. I think that's cool. Now I actually went ahead. So here's what I'm thinking. I'm gonna make this at home. I'm gonna simplify the design. If your neighbor's being a problem, yeah. So here's what I'm thinking. I want to simplify the design a bit. If this will pull up. Come on. Yeah, so I own a mini lathe and I own a 3D printer, but I don't own a welder. So what they would do is they would turn these on a lathe and then weld on the fins. I think what I'm going to do is I'm going to turn this and then I'm going to 3D print this, right? However, I don't quite have as good of articulation on my lathe. Like my lathe isn't a CNC lathe. It's and I don't have like a curve follower and I never ground any. I didn't grind a form tool to cut this curve. So I think what I'm gonna do is I'm just gonna have a taper. And also the stock that I bought just came with a taper on it. So I'm just gonna leave it like that. But here's the thing, chat. I already went ahead and I may have done some work ahead of time. So I actually have a little bit of a video to show you guys. So I'm going to switch over to that real quick. So what I'm going to be using is a piece of this 5/8 inch 4140 round bar. I got the whole thing on eBay for in total about $20 including shipping. So those are pretty cheap. I could set up the lathe compound to cut the taper, but they came with a taper on it. Since it's 5/8, I can just slip it into the 5/8 inch ER32 collet chuck in the collet chuck on the lathe. I'm gonna use this turning tool here, this both for chamfering and for facing. So here I'm gonna just take a couple facing cuts. Put a little lube on it. Makes it cut a little bit better. I don't always remember to put the lube on, but when I do, it tends to cut better. I'm using carbide tools. Yeah. And then after I face it off, I pull it out a little bit more to get more clearance on the sides for turning it down. just loosen it with the wrench, pull it out, put it back in, tighten it back up. Yep. I'm not really measuring it super closely. I'm kind of eyeballing it on this. I'm going for roughly about an inch of threads, but it doesn't, for what we're doing, it doesn't really all that, it doesn't really matter all that much. So here I'm switching to the right-handed turning tool to turn down the side. And again, I add some lube. So I start out taking some very light 10 thou cuts. But then after a couple cuts of that, I remember that if I'm just doing manual feeding and I've got the carbide tool in there, I can actually take deeper cuts if I feed it slower. So I do that and it tends to remove material a little bit faster. And you can see it's getting a pretty nice surface finish even though I'm just roughing. It does take quite a while, so I've got a few cuts here to speed things up. I'm not going to show the whole thing, just kind of cut to the end. Yeah, and towards the end, I was measuring it with the calipers to make sure I didn't overshoot. I very nearly did. I was aiming for between, within the tolerance of the major diameter. I ended up at 0.302, which is like a few tenths under, but like for what we're doing, it doesn't really matter. Those tolerances are quite a bit tighter than what we actually need for this project. So then I put on the thread cutting die in my die wrench, and I'm turning the headstock with the wrench on the other end. I'm going to speed it up because it takes a little while to do this. I switched to my other die wrench because I removed the pedals from that. They kind of get in the way sometimes. Yeah, this takes a little while. And then I remove it, and then I swap it over to the other side to bottom out the threads. And you can see it takes a while in real time. Metalworking takes a long time. Need some patience for this sort of thing. And then I use the wrench to just snug it right up on that shoulder. And then I pull it off. And then I check it with... No? Oh, no. I forgot. I cut a chamfer on the end and on the shoulder just to break it off and make it a little bit smoother. But one of the things I forgot about is that if you cut a chamfer like this in threads, it tends to roll over the thread and it tends to stick a little bit, which is not ideal. But it still works anyways. I think if I were doing it again, I'd probably just use a file instead of the chamfering tool. And then I check it with the nut, and like I said, it sticks a little bit at the beginning because of rolling over those threads with the chamfering tool. And then I decide to get out a wrench and just wrench it on there. And it does go on. Yeah, it goes on with the wrench. And then once it's on, it runs very freely on the threads, engages with them very nicely. So then I just get the wrench out, pull it out of the call it chuck. Loosen that off, unscrew it. And there, we've got the nose of our lazy dog. So now we just need the rest of it. There's the steel part complete. So there we go. There we go. I didn't hear any of that because of how it was set up, but yeah, I hope you liked my narration that I recorded like this morning before I went to bed. Yeah, so I actually have it just sitting here. I don't know if you can hear it, but I've got the nut on it. So now I just need to 3D print the fins, I think. I think I want to use a captive nut inside the 3D printed fins, and I think what we're gonna try to do now is I'm gonna try to do a little bit of CAD design on stream. I'm gonna see how that goes. It might be, I might go a little bit nonverbal. I don't know. But hopefully it works. I'll switch over to this. Yeah, so I've got OpenSCAD over here. I've got Vim over here. I guess I could open up something I've designed before, maybe, just to show off. Would be a good thing. Do I have the cross drill jig? How about fixture.scad? Yeah. So this is something I made before. So just out of curiosity, what is a lazy dog? Ah, yes. Okay, I can go back to that. This is a lazy dog, and it is a kinetic projectile. It is, what they would do is they would mass manufacture these and keep boxes of them in helicopters, and they would throw them out of helicopters. And because of the kinetic energy they would get from falling, they would reach a velocity where they would be lethal. And it was a anti-personnel device, so they would kill people with it. So I think they're really cool. By the way, I forgot to mention this. You could just buy them on eBay. Like there were so many of them produced. There was a huge surplus. You can just find them on eBay. And they're not very expensive. Like, let me, if I hide this, yeah, then I pull it up on eBay, lazy dog. Yeah. So yeah, you can find them like that. I mean, they're a little bit expensive. Rod from God, but with helis. Yeah. Also flechettes, I guess. But yeah, there's a lot of people that sell them. A lot of other bullshit, but yeah, you can find them on eBay. They're completely legal. It's just a chunk of steel with fins on it, right? But I think they're cool. So I want to make one. Yeah, and he already made one, so if he can get away with it, we can get away with it, right? That's how it works. That's how YouTube works. So this is OpenSCAD. And if we do, what this is essentially a programmer's CAD program where you write code to make 3D models. parametrically. And what this model here was, I'm just showing this as an example of something I've made before. This was a cross drilling jig that I made. These orange colored bits here were some brass parts. These two were knurled screws that would screw it together, and this part here was a brass bushing that I used for a drill bushing, and then these V channels here were for putting round stock in, so you would screw it down on the round stock, and the bushing would hold the drill bit perpendicular and centered with the round stock. It was a very, very useful device. Very, very, very nice. And how I made it was these three pieces I turned on the lathe from some brass stock, and then these two clamshell pieces I just 3D printed with 100% infill. Oh yeah, and the holes were to mount it for bolting it down. Yeah, I was wondering how haram this pig you're cooking would be. yeah, no, I'm not breaking any rules. I'm not breaking any rules. But hopefully we're gonna have a little bit of fun anyways. Hopefully. I mean, it is still technically ordnance, right? It is still ordnance. So, yeah, so I think we're gonna go. Oh, and I could show like what the code for this would look like as well, I think. If I go back up, CD, what was it called? Cross drill jig was it fixture.fcat? Yeah. So I had the bushings and the screws and the other files that I imported here. I've got that sets basically how many sides there are to cylinders, because it's not perfect. It does it with like facets. It's not a perfectly round thing, so I just set it really, really high. Then we've got a function to convert from inches to millimeters, because Cura interprets the size of STL files to be in millimeters, and this outputs it like that. So when we want to use inches, we got to use the inches function. And then we've got clearance variable, which, yeah, then we've got a bunch of dimension variables. Some of them are defined based on other ones. I got to get myself a drill press. Yeah. And then we've got some modules for some of the various parts and how that's defined. And then that part, the top and the bottom part, and then the total assembly. Yeah, that is how that is done. That is how that is done. I believe the bottom part had the captive nut feature that I'm going to probably want to just yoinky splinky. Good night, dude. I'll catch the rest later. See you, Squishy. So, let's switch back over. CD Lazy Dog. And we're gonna. Alright, so we're gonna start with our FN equals 200. And then I'm gonna pull this up in my other what is the floating hole trick? Yeah, I can. Let me pull that up. Let me hide this so I don't show off my search history real quick. So it was floating hole trick, right? So this was something I learned from this Hackaday article, which is that if you're 3D printing, what it does is it's like a CNC hot glue gun for plastic, essentially. And what happens is you can't just squirt out plastic in midair, right? So if you want to have a hole that's like upside down where you've got the flat spot over top with a hole in the middle, you've got to support it. And this is a trick for that, which is that you can add just a little bit of a ledge that's like the thickness of one layer. And it'll give it just enough support to put in that last little bit of a hole. But that's something that you have to CAD in. Haven't seen a CD command in years. I like it. Brings the warm fuzzies to someone who grew up using DOS. Yeah, I'm a Linux Chad. I use Linux. Which is useful for streaming. I'm not sure what you mean, what's useful for streaming. I missed the context on that. But yeah, that's the floating hole trick. And so I have the code for that in the other one. I'm probably gonna just yoinky sploinky that. Just copy paste it over. Yeah. So we'll go back over here. I'll get the code pulled up. CD code CAD stuff. Was the cross drill jig? You can use guest profiles in the browser to make a capturable browser for streaming that doesn't have your. That's a good idea. I should do that. I should do that. And then we'll. Oh, it's fixture.scad. All right. So things we want to copy over. We need our inches function. Right? Yeah. And then we're going to need our z-fight epsilon, because there is a kind of an interesting quirk about OpenSCAD when you have things that butt up against them, against two things, or you need to use something like this to kind of break out of that. I think we do want our clearance, but I think we want to change the clearance to, I don't know. We want it in terms of inches, 0.05, maybe 10 thou. Oh, our layer height, that is 0.2 millimeters. We're keeping that. Nut diameter. Nut diameter, nut height. I think I'm using a different size nut, so I'm gonna have to change all of this. Because I think it was 3/8, I think, or 3/16. Yeah, I think it's. Hold on, let me look it up. I think the bolt size I used is a 3/16. I forget what the dimension on the nut diameter is. But then I think we want to copy over all the code for the nut hole. This is a copy pasting simulator. For some reason, YouTube filtered a different version of that message. Oh, yeah, because I'm on top chat. I need to be on live chat. Oh, neat. YouTube filtered my message. YouTube hate. YouTube hate. Yeah. Okay. So. Is there anything else? Yeah, let me. What was the. I think it was a quarter inch nut or a quarter inch bolt, which means 7/16. But this is I believe it was 3/16, right? I think that's what I said, or 5/16. What was it? I think it was 0.3175, right? Yeah, it was 5/16 size bolt. So let me 5/16 nut dimensions. Let me Google that, and then I'll pull it up on my browser to show you guys. It's not a nylon block nut. It's not. That's not what we want. Here we go. Yeah. So our S and our D. I think our S was it gives us, but what we need, I believe, is along here, which is why I do that little bit with yeah, if I remember right. 7/16. 3/8. What was 7/16 exactly? In decimal, 7/16, 0.437, 0.438, 0.428. Yeah, that seems right. For the S, so we need that to be 0.5, so it's a half inch from corner to corner, which means we need this to be half, and then we need to know the K, which is the thickness. They did 0.22, which I believe that was 7/32. 0.21. Yeah. Except I'm putting quite a bit of clearance on this, because what we're gonna do is we're gonna put the nut in the hole and have the printer stop like part way through printing the hole, and then we're gonna put the nut in, and then we're gonna have it print over top of the nut, which is how it's gonna keep the nut captive. That's how I do that. Right, so 273. What is that? Is that quarter? Quarter plus some clearance? Yeah, and then I've got quarter plus some clearance, so we'll do quarter, and then the bolt hole diameter is 5/16 plus some clearance, right? Yeah. do we need to make it even a little bit bigger than that? Let's do... that, I think. And then we'll try this out, I think. Oh, did I not get the whole thing? I think I just missed this last bracket. Okay, and then we'll call it not whole, just to see what it looks like, and then we'll open that up. Parser syntax error, line 6. All right, 6. Oh, I see. We need an equals there. Ignoring variable part height. Right. What do we... Yeah, that's the length of the whole thing. I think we need to define that. We'll define that as... maybe 2 inches? I think we'll go 2 inches. I think that's set in a little bit deeper than what we want it to be, because I only made this to be about an inch in, like about an inch of threads, and we want the nut to engage about halfway. So I think I'm gonna set this to be just 1 inch, and then we'll translate this up. Inches height over 2, maybe. That did not do. Oh, because I already have it. I have the part height in inches, so that's not necessary. That's not what we wanted. Part height times 2.1. Is that what we need? Just kind of weird. Yeah, that's a little bit odd. But I think that'll do what we want. You mentioned using Linux. Which distro are you using? I've been using Arch Linux since I think around 2012, I want to say. Yeah. I just recently installed it on this computer because this is a new computer, but I've been using it on my other computers for a very, very long time. Yeah. I think that looks right. I think that looks right for our nut hole. And then, all right, so now we need to define the fin. So I'm going to comment that out for now. And we'll do the fin width. We'll go with, this is going to be our dimension from the tip of the wing to the, we'll go from the tip to the center. Or maybe that should be fin length, I don't know. we'll do fin length. Yeah, so we'll go with I don't know, half an inch. And then fin base thickness, I think we'll do a quarter of an inch, I think. All right, so now we need to do, I think the way we're gonna do this is with a polygon. Let me pull up the manual. So I think what we're gonna do is we're gonna start with a 2D polygon and we're going to extrude it, but make it extrude up to a point so it's like swept like a fin kind of ought to be. Yeah, polygon. Okay, so we got to define the points. So fin base points equals that, and then we'll tab it in. So we'll start with x0, y fin length. Yeah? And then the next one, we need to do x fin base thickness over 2, and then we'll do fin base thickness over 2. And then the next one we'll do x fin length, and then y0. And then the next one we'll do fin base thickness over 2, and then negative fin base thickness over 2. Oh, I got added a comma there, didn't need it. And then we'll do negative fin length. Or no. We need that in the y. We need 0, negative fin length, and then we'll do negative fin base thickness over 2, base thickness over 2. And then I think that's the last one, because then it goes back up to the top, right? Yeah. So now we do a polygon points equals, what do we name that? Fin base points. Oh. There we go. And then we'll close that off. Got some undefined things. Fin. Why is that undefined? Ignoring undefined variable, fin base thickness. 24. Oh, because equals inches a quarter. Yeah, that's why. Okay, so looks like we skipped a thing. Looks like we skipped a thing here. This is also a bit thicker than I'd like, but we can fix that. So it goes straight from the negative y. So we need to go from there to a negative fin base thickness. Oh no, we need to go from here, yeah. Negative fin base thickness or 2, negative fin base thickness or 2, and we need length negative or would be wait. No, this goes here. Yeah. And then we do negative fin length and then 0. There we go. There we go. There's our star. I think I'm going to lower the base thickness. Actually, let's do 3/16, and then I think we'll raise this to maybe 3/4 inch. Ah, that looks like a good base cross section. Yeah, I think we're getting somewhere. All right, so now we need to linear extrude this. We need to linear extrude it. What was it? Part height, right? Linear extrude. What was the syntax for linear extrude? Linear extrude height equals, fuck, I already forgot. Part height. Part height. Oh, except I need that to not have a semicolon. Yeah, okay. And now, the magic part, we need I actually need to pull up linear extrude because it's not listed here. Linear extrude. Is it scale? Scale equals 0. There we go. That's looking like fins. That looks like fins, I think. I think we got some fins. Huh? But now we need the central body with which to contain the nut and to mate with the nose of our lazy dog. So, again, we'll comment this out. And I think we want to do, we'll define it as, and I think we want it to be, I think we want it to taper off a little bit. So we want the body top radius equals, what was the diameter? I think it was 5/8 over 2. And then the body radius, I don't know. So it's a 5/16 bolt, right? I think we'll go with 3/8 maybe. We'll see how that looks. Inches, 3/8. Or 2. We can always change it. And we'll come back down here and we'll do cylinder. R1 equals body top. I think R1 is the bottom radius. R2 equals body top radius. Oh, and then we need the height. And then height equals part height. Was it H? It's kind of inconsistent. Sometimes, yeah. Okay. Yeah, that looks right. And now we put everything together. So we've got a union of this, our cylinder, and then our fins, yeah? And then we need to difference from that. We'll tab that out. And we'll difference that from our nut hole, I think. Yeah? That's a little bit glitchy. And I think our nut hole is defined with the z phi epsilon stuff already. Do we need a convexity somewhere in here? Convexity equals, no, it wouldn't be here. V under the linear extrude, I think. Convexity equals 5, we'll just say. However, I don't see the nut hole. If I zoom in enough to clip through it, does it show the nut hole? I think we want to increase our part height too. Let's make that 2 inches. I think that looks a little bit better. I'm not sure why we're not seeing the nut hole. What if I do this? Oh. Why are you way the heck up there? What the fuck? What the fuck? I guess let's just raise that. Like that maybe? That's a bit of an issue. That is a bit of an issue. We don't want it clipping through the side like that. Is that really that close? Yeah, it kind of is, isn't it? I hadn't noticed that. The nut is that close to the size of our, the dimension of our body. Well, let's do, I don't know, our height times 7/8. Eighths. We'll just get rid of the R2, I think, and just do a single radius all the way down. It's gonna look worse, but is that what it needs? Huh? Oh, that isn't in there. That's why it's not removing that, isn't it? We'll do top radius, how about? And then get rid of that. Does that look good? I think that would do it. I think that'll do. I think that'll do what we need it to do. I'm worried that that's not going to be enough meat on it. But it really doesn't need to be very structural. It just needs to hold it on there. Because it like all it is just fins, right? Like if it hits the target, it's gonna snap off, but like at that point it's already hit the target. I think that'll be fine. Let's render it and then save it as an STL file, and then we'll switch over to Cura, and we'll open the file, and I crashed Cura, right? Because was what was the thing to get Cura with that? Fuck, what was that? I remember Cura seg faults if I don't open it with a very particular option. Yeah. Platform theme equals GTK. Fucking Cura, man. Fucking Cura. And I imagine I'm probably gonna need to add the, oh no, it's in OBS. Okay. It's in OBS. Can we open the file? And then we'll go to our code, CAD stuff, lazydog.stl. There we go. And it isn't showing it anymore. Okay. There we go. Slice it. Take an hour and 40 minutes. Wait, what's my infill? We need more infill than that. I'm thinking maybe 80% infill. With cubic infill, I think. Let's take a look at how that slices it. God bless usability on Linux, because damn doesn't need it. Yeah. All right, let's see what that looks like. Oh, I need to get rid of the. I don't like the skirt. Get rid of the skirt. All right, let's. Oh god, that's freaking thin. That is thin. Yeah, it clips right through there. It's not gonna match up, but I think I need to make it just a little bit thicker than the actual steel body, unfortunately. Let's see. Next step up from 5/8 would be 3/4. Oh, that looks goofy. I think we need to make the fins larger to compensate. We'll make them 1 inch. Yeah. Alright, save it, and Cura should update automatically. Or reload, slice. Alright, let's see what that looks like. Why is... Oh, I was just looking at it weird. Okay. So if we go down... Yeah, that looks a lot better. That looks a lot better. And if we go up... Yeah, you see you get 1 layer there, and then 1 layer like that, and then the circle. So that's what I'm talking about with the whole trick. Is you can't just print over nothingness. You have to have something to bridge to. Like you can bridge over air, but you have to start at somewhere and end at somewhere. If you've got just a hole over nothing and you try to bridge there and then stop at the hole, that's not going to work. That 3D printing doesn't let you do that. So I think that looks good. I think that looks good. Hour and 54 minutes. I think I'm gonna save that as our lazydog.g code, and I'll get that 3D printing tonight, and At least not extruder based 3D. It is extruder based 3D printing. It's or oh yeah yeah. At least extruder based 3D printing doesn't let you do that. Yeah. And yeah, I am using FDM 3D printing. I just have the real basic stock Ender 3. So are you going to stop the print half? Oh right. I forgot. I need to add the thing that stops it there. So that is layer 195. Extensions, post-processing, modified G-code, pause at height, pause at layer 185. We'll pause it at 184 just to make sure. Yeah. And then we'll slice it again. Wait, it wasn't 180, it was 190. 194. All right. Thanks for catching that. I would have completely just missed that. So what that's going to do is that's going to insert G-code to stop the printer part way through. And then, yeah, and then we'll be able to put the nut in and then hit go and it'll print the rest of it over top of the nut. And then I should be able to screw my nose just right into that and it should just work. And we'll have our lazy dog. I think we're done. I think we accomplished what we wanted to accomplish. And I think we just barely skirted the various rules involved by not having any explosives. And Wikipedia does call it a bomb, so just like the Bo Burnham lyric, here's how to build a bomb. Well. It's been good. It's been a good stream. This is a lot of fun. I'm again, like I always say, I'm very, very thankful to anybody who shows up and listens to what I have to say. Because sometimes it's spicy, sometimes it's boring. I think I'm gonna read names now. Squishy, thank you. Super Iron Bob, thank you. Tor Arn Mathiasen, thank you. Yeah, that's everyone. Thank you guys for showing up. This was a lot of fun. Yeah. A much smaller version than the one that took out the Iranian general. I didn't know there was one that took. Oh, was that the Sidewinder, right? Let me look it up on my off-screen browser, and I'll bring it over. I think Iranian general assassination. Was it this thing? This thing? Nope, concrete bomb. Oh. Was it this guy? Is this the one you're talking about? Delivered the payload. MQ-9 Reaper. Several missiles. Doesn't say what they were though. me Google it. Crete bomb. Iranian general. This thing, maybe? Does this tell us? I want a picture of it. I want to see a picture of it. Yeah, it was this guy. Okay. Does it say concrete? Alright. What if I search this? No. No, not there. Not in our chat. Seem Soleimani. Kinetic. Bombardment. Google. Does this show us a picture? No, it doesn't. Let's Google images. Google images. Is it this thing? No, it's got like labels in. I don't see any pictures of it. I don't see any pictures of it. I've got safe search off. They have neither confirmed or denied what was used, but considering the lack of collateral damage, it had to be a kinetic system used. Maybe. I don't know. It'd be really cool to see it. I want to see it. I want to see it. But I guess they don't want us knowing their super secret government tech. Anyways, I read names. I really appreciate you guys coming. I had a lot of fun. Yeah. You guys have a nice night. I think I'm going to head out. Thank you guys for coming. Stay safe. Stay healthy. Have a good one. Bye-bye.